Disclaimer. This video is for educational purposes only. It demonstrates attacks to raise awareness of security vulnerabilities and teach ethical hacking practices. Important. Always use these techniques responsibly and legally with the explicit permission of the system owner. Unauthorized hacking or malicious use is illegal and punishable by law. Goal. To educate individuals on improving cybersecurity measures by understanding potential attack methods.
We're going to see methods related to F5ASM module to secure our web server resources. So for example, we don't need to permit showing critical files on our web server like etc password, etc shadow, and all that kind of sensitive files inside our web server directories. So F5ASM module can help us protect against those kind of attacks, like for example, local file inclusion, remote file inclusion, file upload vulnerability, and also forceful browsing. So the first example that we will talk about is something called local file inclusion. It's simply a trial from the attacker to track your web application by asking for a critical file inside an input form. So instead of entering the expected value inside the form or inside an input field using HTML code, the attacker will enter a specific path to a critical file inside this parameter. Like if we have a page like what you see here, and there's a parameter inside it called PHP, it's expected from the client to enter normal text inside this parameter. And instead of this, the attacker will try to enter a path related to a critical file, as you see here, etc/password. If your web application is vulnerable to such attacks, files will be shown to the attacker, as you see here. So all things related to this file will be shown to the attacker, then leakage happening. So our lab today will show us how ASM module is going to help us against these kind of attacks. Another attack here is called remote file inclusion. It's usually used to include web shells that are hosted remotely on other servers. By including those types of files, attackers can control and attack the web server remotely. So simply, if the web application is vulnerable to this kind of attacks, the attacker can inject its code into the web application itself. But this file that's considered malicious is not hosted into the web server side. It's hosted on the attacker's machine. The web application will connect to this file like a reverse connection to the attacker's machine or any other machine. So for this reason, it's called remote file inclusion. Let's take an example here. Suppose that I have this web application here, hack it yourself action, and I have a parameter here called ID. And instead of entering the normal text value of the ID here, which is expected from the client, the attacker will enter this value, as you see here, ID equal another URL. So this URL exists on Kali Linux here. So there's a file here called simple backdoor PHP, and it's hosted on this remote server. So I will include this file on our web application here through connected to it. So for this reason, it's called remote file inclusion. By doing so, I can execute some commands that will be accepted from this file, like for example, cmd equal pwd. By typing this command, I can view the directory that I am on it right now here on this web application. So again, remote file inclusion will launch an attack because of a file hosted on a remote server, not locally on this web application. And here's an example also. And the example is shown to you here. I used here a simple web shell and I ran it through Python to receive the connection from this web application through port 5000. So the client here or the attacker here entered this URL into this ID. So the web application, if it's vulnerable to this kind of attacks, will connect to Kali Linux as a reverse shell or as a backdoor. And then the attacker is able to run any operating system command to get information about this web application and to execute things also on this web application. So all of these attacks that we are speaking about, whether it's local file inclusion or remote file inclusion, are considered attack signatures, need to be applied on the level of ASM module. By default, local file inclusion are enabled if you choose the comprehensive mode, and because of we enabled some of the technologies related to our web application, so this attack will be blocked by default. But according to remote file inclusion, we need to enable this signature set, because if you opened attack signatures in learning and blocking settings, you will not find such attack set enabled here in this panel. So we need to click on a change and search for something called remote file inclusion signatures to be enabled here to start defending against those types of attacks. This takes us to a very important note. Not all signature sets are enabled by default. According to template and also technologies that you are using in your web application, specific attack signature sets will be enabled. But of course, you can enable all attack signature sets if you need, or for example, you can increase those sets by time if you need to enable this, of course. Finally, we have file upload vulnerability. It's another trial from the attacker to start exploiting file level vulnerabilities that could be existed on your web application. The attacker can upload a malicious script that could be executed on your server side to open a reverse connection, for example, or leak sensitive information. Here we can see an example here. Inside this parameter, we can upload images, right? If your web application is vulnerable to such attacks, the attacker can upload another type of file, like for example PHP, or it can mask this extension by using another tool to track this web application. If images only are uploadable to your web application, the attacker simply can mask this extension by another extension and re-upload it again to your web application. So your web application needs to understand that this file is a script, and it's a trial from the attacker to exploit some vulnerabilities inside our web application. This is the rule of ASM module, and we are going to see how it can defend against these types of attacks. So what is forceful browsing? It's a trial from the attacker to access files of different directories that aren't permitted to be shown to the clients. It's allowed always if the server is misconfigured and not secure enough to defend against those kind of tries from the attacker. Okay, so again, speaking about this part, we are dealing with the positive security model, and it's a clue for the importance of the positive security model of F5ASM to build the policy correctly. So security for this attack would be done using the positive security model, not attack signatures. So by defining all these URLs only and deleting wildcard, then any trial to access any other URL inside your web application will be considered a forceful browsing, and you will see this notification inside event logs after we try this attack on our web application. So again, what is the secret here? The previous types of the attacks that we have tackled before related to the negative security model, because we are speaking about attack signatures. Here, for the forceful browsing, after declaring and defining all the explicit URLs inside our web application, we are going to delete the wildcard. Then, if the attacker tried to access any other URL that's not defined into our explicit URLs, the attack will be blocked and it's considered a forceful browsing. Another problem here might face us is simply the client can access some URLs that are defined in the policy. Okay, so it's not undefined, it's defined normally, but the client or the normal client can access those URLs, and I don't need to do so. I need the user to be authenticated firstly to be able to access these URLs. We have spoken about this before in the previous sections of this course, but we are going to review it here using the login enforcement. So for specific URLs, again, I don't need the clients to connect to these URLs or to open them unless they are authenticated against our login page. That's what we call login enforcement. Okay, so again, we have three main portions of this lab. The first one is about negative security policy. We need to apply all the attack signatures related to three main types of accessing our web server resources: local file inclusion, remote file inclusion, and also uploading a vulnerable file to be executed on our server side to open, for example, a reverse shell. The second thing is simply to make sure that we have enabled the positive security model correctly by defining known URLs inside our web application and then deleting the wildcard, so any other trial from the attacker to access undefined URL will be blocked and considered a forceful browsing. Thirdly, we need to also enable the login enforcement to be able to authenticate clients before they access sensitive or critical URLs, as we are going to see. Okay, so let's try some kind of these attacks that we have tackled in our slides. For example, I'll try to initiate a local file inclusion here to be shown to me, like for example etc/shadow. I think if you enabled your attack signatures correctly, then this attack must be blocked. Of course, also if you tried any other type of the attack like the remote file inclusion, the attack will be blocked. So let me try here something related to the local file inclusion. So for example, the attacker needs to read this file, which is called etc/shadow inside our web server repositories. So here I will type etc, for example, and then shadow. Then I will click go on the level of this parameter, which is called username. Click go. So request rejected, and this is our support ID. Let me copy the support ID, and I will paste it on our ASM module event logs to see the results. Okay, let me paste it here. Click apply. Then this is our request that was blocked. Here you can read that this is a predictable resource location. So ASM knows well that it's tried from the attacker to read your resource files, and it was blocked correctly. If you click on all details here, you can read much information about this kind of attack. What is the policy that's applied? What is the session ID? And so forth. Let me try another thing here. I'll try to upload a vulnerable backdoor PHP file that enables the attacker to establish a reverse shell to your web application to start giving it some commands and instructions to be run on the server side. For example, I will click on sell an item here. Then here I can upload an image, right? And instead of that, I will enable a PHP file that's considered a backdoor called simple backdoor PHP. Let me double click on this file to start uploading it and see the result. If I click submit here, the request will be blocked, and this is the support ID for our blocked request. Let me copy this one, and then I will paste it here under support ID. Then I can read information about why this request is blocked. So as you see here, we have two main types of violations related to the positive security model and the negative security model. The positive is related to the parameter value length. Okay, that's noticed. For the attack signature, there is an abuse of functionality and other application attacks, because here ASM module can inspect on the level of the file. So after it uploaded the file, it tried to extract the contents of this file. It detected that it's a kind of backdoor from the attacker to our web application. Okay, finally, let's speak about the login enforcement and also the forceful browsing. Before we speak about login enforcement, we need firstly to see how forceful browsing attack is working and how our ASM module is going to help us defend against these types of attacks. So again, it's based on the positive security model. In the first stage of these labs, we have tackled that we need to build our security policy by trying all the possible legitimate scenarios for the normal clients to be admitted by ASM module. So it learned all the entities or all the possible entities related to your web application, and then we deleted the wildcard, so any other trial from the attacker to access undefined URL, this trial will be blocked and considered a forceful browsing. So here I am on ASM module. Let me try to see the URLs that were defined in the first stage of these labs. Here we have multiple URLs, as you see, and they are all defined here, but keep in mind we have still the wildcards. We need to delete those wildcards entities. So I will check those wildcards, and here I will click delete to delete these wildcards to be matched only with the explicit URLs that were defined during the learning process. Okay, and I need to try something else rather than those URLs that exist here to see how can ASM module help us defending against forceful browsing. So suppose that there are some URLs that are sensitive inside our web application and I don't want them here to be defined as an explicit entity. So this URL of course could be considered a forceful browsing attack from the attacker if it needs to contact with it. So let me apply the policy firstly. Let me get back to our client here. What we need to do is we need to see if I entered anything here as a URL for our web application rather than the defined URLs. We need to see that blocking message, right? Because we are applying the positive security model. For example, let me type here anything.php. What is the result here? Blocked. Why? Because this URL is not defined into my policy. Then I will block you. We can see our event logs here. Let me open event logs application and request to see the result of blocking. This is our URL that we were trying to access here, telling you that the attack types is forceful browsing. So the attacker is trying to access some URLs that are not defined into your security policy, and because of this I block the traffic as an ASM module. Finally, we need to make sure that a specific client will not be able to access a specific URL unless it's authenticated against the login page. To do so, we need firstly to define some login page and what are the conditions that we need to put on this login page to authenticate our clients before they access a specific URLs. Let me open here application security and then security policies and policies list. This is our security policy. I will click on it because we are on a new version from F5 16.0.1, I think. Let me double check this. So we are on 16.1.3. Because of this, you will see some differences for the GUI. Login enforcement panel became sessions and logins on the level of the security policy. So I will open policies list. Then I will access our security policy here. We have here among the options something called sessions and logins. We can click on it. Then here we can define our login pages. So if I click on add a page, you can put your own login page here. In our case, we are logging through a page called userlogin.php. The authentication type is HTML form, username and password. You need to put the parameter name here, it's username. The password or the parameter password name, it's password. Related to our web application, I will choose the condition to be sending a status code to be 302 because related to our action.php website, if the user authenticated successfully, this status code will be sent as a response to the client to be redirected to another page related to our web application called your data. So my condition will be expected response code. Then I will put 302 and here I need to put the username parameter and down here I need to put the password parameter, and also I can declare the URL here. As you see, you can choose any URL here. For example, you can choose login page. We have two main pages actually. The first one, which is the index.php, it contains login pages because it contains the login form, and also we have a separate login page called userlogin.php. After you finish your configuration related to your login page, you can click add and then add another page. Okay, let me show you why I bought 302 here. I'm here in Kali Linux. Let me log in firstly. I'll start my purpose suite as a proxy. Okay, we will speak about purpose suite in the upcoming videos related to other attacks, but for now I will use a proxy here to start showing you the response part from the web application to our client. So Kali Linux considered a client trying to access our web application, right? So I will here click on intercept and make the proxy working. Let me open Firefox again. Okay, let me try to log in here. Let me get back to the proxy, and then here I will forward the request. Forward. Okay, so here as you see I logged in successfully. Let me get back to the proxy and go to HTTP history to show you the response part. So here let me see the response. As you see, there's a code here called 302 and it's found. So this is my condition. I put into the login page after the user is authenticated successfully, and you see this response code here. Then you can consider this trial from the user is authenticated, and then he can access the URLs that I will put inside the login enforcement policy, as we are going to see right now. What I need you to understand here is that the response code is a part of the response, so I put it into my conditions related to the login enforcement. Okay, so let's complete our login page or login enforcement lab. So here, after you define your login page, for example, I defined login.php and also userlogin.php. Once you finish defining your login pages, you can also define your logout pages. Let me do so. So I will here choose the URL of logout to be my logout page. Then if you have some strings to be expected into the request or unexpected string, you can put some conditions here. I will not do anything here. I will click add, just add. Then here for the login enforcement, if you have some intents to put some session expiration, so you don't need to let the user do whatever it wants without any expiration. If you want to put some expiration here, you can click here after and then you put the seconds that you want. For example, let me try this. So I'll put here 10 seconds only. And what are the authenticated URLs that you need this client after it authenticated successfully to your web application to access? So for example, here I need this client after it authenticated successfully to access this page, which is called cell.php. So this is the protected URL that will not be available for the clients to be accessed unless they are authenticated successfully to our web application. Let me click save here and click apply policy. So what are the expectations here? Simply, if the client wants to access cell.php, he will not be able to do so unless he is authenticated successfully to our web application. And after 10 seconds from this process of authentication, the user will have its session expired and needs to log in again. Okay, so here's our client. This is the normal client, no Kali Linux. What if I try to access sell an item? See, the request is blocked. Why? I have sell.php is defined into my URLs because I applied login enforcement. We need to log in firstly before we access this page. If we need to make sure that this is the actual reason for blocking, we need to go to event logs application and requests. Then here you will find that it's a login URL expired. I don't think that's the actual reason. It must be login URL bypassed, but because I was logged in before using this browser, so it was hit by login URL expired. Okay, let me clear the cache and open another browser and see the result again. Let me close this browser completely. Let me open Firefox and then I will open incognito new tab. Then I will try to log in with a completely different username and password. Okay, let me open PHP action here. Let me try to log in. Okay, I will not log in with any username and password. Let me access sell an item. Request is blocked. Let me refresh my requests here. Well, let me access this one here. As you see, login URL bypassed. This is the type of the threat and it's also considered a forceful browsing. Very good. So what we need to do is to log in successfully and see if we can open sell.php or not. Let me try to log in with a username called student or for example guest33 for the password. Okay, good. Let me access sell an item. Okay, so right now I'm able to access sell an item page without any problem. So this is what we call login enforcement to defend against forceful browsing with all types, whether you have the URL or you don't have the URL inside your repository.